Hello, let's talk about mass-to-mass stoichiometry. So for mass-to-mass, we've already figured out before going from a mole to a mole, from mole to a mass, mass to a mole. Now we're going to go from the mass of a given to the mass of an unknown. And it's going to be 4 steps. So just like anytime we do anything, we need to look at what we have and we need to identify 2 things. We need to identify what we're given. So if we look at our problem right here, it says given 36.1 grams of B2H6 and calculate the mass of oxygen needed to burn off the diborane. So we're going to underline, we're going to circle our unknown. So underline the given, circle the unknown. Then we can come over and we can do our K and our U. So K equals U equals. And anytime we're going from mass to mass, we need to find molar mass. So we need the molar mass of K, and we need the molar mass of U. So if we look at our statement, we know that this is going to be 36.1 grams of B2H6, and we're looking for the grams of oxygen. So we go to our handy dandy periodic table, and we know that there's going to be 2 borons, 6 hydrogens. We know that boron is 10.81, and we know that the oxygen is 1.01. And when we do the math out, we get 27.68 grams per mole of B2H6. Oxygen is relatively easy. 2 times 16 gives us 32 grams per mole of oxygen. So we have our known, we have our unknown. Now we need to take a look at the equation. So we have in our equation B2H6 in the presence of oxygen burning to become diborane and oxygen gas. So we need to balance it because if you see there's 2 here and only 1 here. So when we end up balancing, we're going to end up with 2 moles, 1 mole, two moles, and 3 moles. So looking at our K and our K is B2H6, and our U is O2. So if we come and we look at our balanced equation, we see that the mole ratio is going to be 1 mole of B2H6 to 3 moles of O2. We just need to figure out our logic path. We're going from the mass of A to the mass of B are unknown, but we can't go straight there. So we have to go mass of A to mole of A to mole of B to mass of B. That means 4 steps. So we need to make 4 brackets. We know that this is going to be the grams of our given. We know that this is going to be the moles of our given. We know this one is going to be the moles of our unknown. And we know that this one is going to be the mass of our unknown. So if we've got grams here and we have moles here, that means we have to have grams down here. This is where our molar mass is going to go. Now we're looking at the mole ratio between these two. And molar mass of the oxygen. Okay, so let's put some numbers in. As you know, since we are not doing double dimensional analysis, we could just put an X there or a 1. So we have 36.1 gram. We calculated the molar mass as 27.68, and that is for 1 mole of diboron. Now we need to look at the mole ratio for these. So we know it takes 1 mole of B2H6 for 3 moles of O2. Because we've got it right here when we figured it out from the balanced equation. Now we come over here to the molar mass of oxygen. Well, that's 32 grams for every 1 mole. So we've got everything plugged in. Let's get rid of things we don't need. We don't need these grams and these grams because they're the same, they divide out. We don't need these moles and these moles because they're the same, they divide out. We don't need this mole, we don't need this mole. And we were left with grams of oxygen, which is what we're looking for. So we can also get rid of this one and this one. Now, nothing else really cancels out. So because it doesn't cancel out, that means we have to keep it. Okay, so we've canceled out everything that can be canceled out. Now it's time to do the math. So set up your bracket, open parentheses. Anytime you do math with a calculator and it's more than 1 step, use parentheses. You've got to remember modes of operation. So we're going to write down 36.1. We're multiplying because they're side by side. So we're going to write down to 3. Then we're going to write down 32 grams of oxygen. Now down at the bottom, we have 27.68. And we need to close our parentheses. When we put this in the calculator, if we're going to do it in 1 step, you have to have the parentheses before you hit the divide sign. So in the calculator, it'll look like this. 36.1 times 3 times 32, close parentheses, divide 27.68. And that gives us 125.20 grams of O2. So when we follow these steps, it allows us to get the answer relatively simple. Remember, circle and underline. Make sure you balance the equation. Make sure you find the mole ratio. Write the mole ratio down. Calculate your molar mass for your known and for your unknown. Do your logic path that tells you the steps that you're going through. Build your brackets, fill in the brackets, do the math. Double check your math. Run it twice. It's nice. Any questions? Text, email, stop into a virtual classroom, anything like that will help you out.